So how did you, is it always the first, like the 110 and then the 4 over 34? Is it always like the first and the last one?
Yeah, that's the safest way. The table will have a constant rate of change. It's going to be the same all the way over. So it doesn't matter.
Are you gonna,
Okay. Yeah, Hanjul?
are we gonna have questions like a table like that and then like how tall it's gonna be like after 6
No.
months or something like that?
No. I would have liked to, but that's just one of those things. I know those questions take a lot of time, so I threw them out because we can be more productive with other questions. Yes,
Do we
Amanda?
need to do both of those things?
No, just one way. Either way.
And could we go over finding an area of a triangle with a given vertices?
Yes! Area of a triangle given the vertices. This is from chapter 3, matrices, and that is page 191 is our formula. So the area is going to equal 1/2 times the value of the determinant, and again, you can use your calculator for this. 1/2 times the value of the determinant, and the determinant is x1, y1, 1, x2, y2, 1, x3, y3, 1. And we'll look at an example with this. So it's 1/2 of this determinant. And remember that the determinant, if it's negative, you just take the absolute value of it, make it positive. Do not have a negative area. That shows me that you're not thinking about your answer and seeing if your answer makes sense. It's an area question, you have to have positive areas, no black holes. So if we look, hour always goes fast. If we look here, and I'm recording this, I'll send this, and I'll record the recording from third hour I'll send to you also. Okay. So if they give you a triangle, and these are the vertices, it does not matter which one is x1, x2, and x3. But you notice they just put all three of the points in there. So they put 0, 0, 1, 4, 12, 1, negative 2, 8, 1. They found the determinant. This is using diagonals. You can use your calculator also. Remember, your calculator will find the determinant for you if you use the matrix menu. Yes?
So there's always going to be the 1 in the third.
Yes. It's always 1s in the third row.
Just for the triangle?
Yep. Yep. And that's the only determinant you're going to have to find.
An example.
This is your example.
No, I mean like you make up numbers and we do it.
I would, but we only have 15 minutes left. So this is your example. Okay. We still got several things to go through yet.
Can we use these calculators?
Yes, you can use your calculators.
So you're not going to require to like do it by hand?
Correct. I'm not requiring you to do it by hand. You can use your calculators with this. Do you want me to show you where that is again?
Isn't that like second matrix?
Yes.
And then you just put the columns, like for this one, we do the 3 and 3.
Yep. So on this one, this is your matrix you're going to put in there. So you go second matrix, and you have to edit. And I want to make it a 3 by 3 matrix. I'm just going to type in that matrix. Yes. Type it in. take half of that. That's your area.
I have a question. Chapter 2, when it says evaluate the stack function and piecewise function and the given value, what do you mean?
I'll show you that once we're done with this. Okay, that's good. That's one of the things I was going to go over for sure if no one asked. Okay, so everyone get it in? So what I would do now is 0.5, that's the 1/2, times, go back to your matrix, you're going to go to the math part of it, and option 1, DET, determinant, 0.5 times the determinant, and then select matrix A. So you get 28. Okay, so it'd be 28 units squared, squared units, if they give you a label, square feet, square meters, square centimeters, all of that. Okay. So again, on that page, page 191, you look like some other examples. We did several of these problems. If you remember this donut box, that assignment. That's when we did that. Okay, had a question here. What's your question also? While we're on that same category, how to tell if two matrices are inverses? Okay, you have to multiply them together, and you should get the identity matrix, which is 1, 1, 0, 0, 1. Okay. And you can use your calculators for that again. Two matrices are inverses if their product is the identity matrix, which would be 1, 0, 0, 1. Because the identity matrix, you can multiply by that, and that doesn't change anything. So you'd have to take A times B, and it has to equal I, the identity matrix. So it's going to be two 2x2 matrices. You can use your calculator to multiply them, or use matrix multiplication. It's not a just straight across multiplication. Remember, matrix multiplication is row times column. And if you do it by hand, which you can use your calculators. Piecewise functions, evaluating piecewise functions. A piecewise function is when you have different pieces. So let's say f of x equals 5x minus 1 if x is greater than 3, or let's go less than 3, and equals 2x squared plus 4 if x is greater than or equal to 3. This is what piecewise functions look like. Huh? That is a less than, yeah. Wrote it wrong the first way. Because you have two different rules depending on what your x value is. So you evaluate f as 0. Now this 0, where you look first is over here. Where does 0 fit in? Because this is where the x usually is. Is 0 less than 3 or 0 greater than or equal to 3? Less than. So then that makes this the rule that you're using. Okay, sure you see what I'm looking at here. That makes 5x minus 1 the rule. So since 0 is less than 3, we want to use 5x minus 1, and we're going to plug in 0. So 5 times 0 minus 1 is -1. So that is the answer. The answer will be a number. Okay. Can't please don't draw on this. So it would be f of 5. So the 5, you look on the right side first. Is 5 less than 3 or is it greater than or equal to 3? Greater than or equal. So that means you're going to use this formula, 2x squared plus 4. I'll give you options. Is it 104 or 54? 54. Okay, 54. Make sure you use order of operations. Do the exponent before multiplication. Okay, so that's what the piecewise evaluating piecewise functions is. You need exponents? How do you do exponents?
No, just gonna find
Yeah, just type it in. Okay, greatest integer function. That will be f of x equals this. This is the symbol we used. Plus 3, or it could be the double brackets. If you look at your quiz from that covered this stuff, then you'll be prepared. This is the greatest integer. Evaluate a step function of step function. This is step function.
Oh.
Sorry. Several names for that. Greatest integer or step function. This was your round down function. You always round it down. Okay, it's down because these little brackets are on the bottom here. So if I have f of negative 7.2. Those symbols mean the same thing. So it can be presented either way. You're going to do it the same way. Okay. A ceiling function would turn these around to the top. This is a floor function. So what is the greatest integer less than 7.2? So round down negative 7.2. So if this is negative 7.2 here, if I round it down, I go down to negative 8. If I was at positive 7.2, I'd round it down to 7.
Oh.
7. Okay. So this is missed by quite a bit. I remember from the class on the test when we had this question, so maybe go back and find that test and look over this question. This would be negative 8 plus 3, so our final answer is negative 5. Chapter 2.
In here, like to negative 7.2, and here the 5 and the 0, it just.
They will be given to you.
Oh.
Yep. The formula, and it's just going to say evaluate this, and then this is your answer.
So they're gonna say evaluate this with that formula. So you're gonna hit the number in the formula.
Yep, they will give you this number, they'll give you this formula, you just have to plug it in and calculate which one to do.
And in the size function, we're gonna have the formula and the numbers.
Correct.